Hello everyone, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today I am going to present the topic fourth order RK method, which is an important numerical technique used to solve ordinary differential equations. The method belongs to the unified and of statistics and numerical methods. It provides a more accurate solutions compared to Euler's method by considering multiple slope calculations within a single step. So let's recall with this. In this, before learning the RK method, let us recall ordinary differential equations. An ordinary differential equation contains a derivative of an unknown function. Many differential equations cannot be solved easily using analytical methods. Therefore, numerical methods are used to obtain approximation solutions. One of the simplest method is Euler's method. However, Euler's method may produce significant errors when the step size is too large. So next we move on to the empathy stage. So in this stage, let us understand the need for a better numerical method. Suppose an engineer wants to predict the motion of a vehicle, aircraft or mechanical system. Small errors in calculations can produce inaccurate results. So here the first step is the accuracy is important, and then therefore we need the method to give a higher accuracy without making calculations extremely difficult. So this need leads us to the RK method. So here we are using that computational load and the applications are discussed. Next we can define the we can move on to the define stage. So the problem can be defined as follows. So for example, we can choose one problem. In this problem, high accuracy is very main important, and then it is widely used in many in various scientific and engineering fields, and the high accuracy for solving differential equations is RK method is a best method, and the cost is very high. The computational cost is very high, and the RK method's accuracy is highly dependent on the chosen step size. So for example, we can choose one problem, the differential equation dy by dx equal to a function of x comma y with an initial condition y of x not equal to y naught, and we need to find the value of y at the future points. Instead of calculating only one slope like Euler's method, the RK method calculates several slopes and combines them to obtain the more accurate results. Next, we move on to the ideate stage. So in this stage, we can, and based on the problem statement, we can ideate the step-by-step process. So first one is calculate the increments, and second one is update the solution and increment time, repeat. This is the stages we are using. So computational, so, com so the compute four slopes, calculate increments, compute four slopes k values at different time points. So K1, K2, K3 and K4. So each slope provides information about the behavior of the solution at different locations within the interval. And we can, the average weighted average of these slopes is then used to obtain a highly accurate estimate. So next we can update the solutions, update this value of the y using the weighted average slopes, and the time to updating the time to the next discrete step, and repeat the process that for the desired number of steps we want to continue with this. So next we can move on to the final prototype stage. So the RK method, from this, in this stage we can come to a conclusion based on the result. So first initially we are calculating, and in initial conditions and step size are all we are discussing. First calculating k1, k2, k3, k4, and then we are calculating that final y1 values. So that based on that y1 value, if the process, the weighting of average k values, if it is okay for this, the slope is end slopes of the interval is, we can based on the problem statement we can decide, we can stop or we can continue, repeat the solution, we can continue or not, we can decide in this stage. So if you are for the we are n equal to 1, we can continue the process for the next interval. So next, finally, based on this result, accurate results, we can go for the conclusion. So finally, some areas are used in our RK method. The RK methods are used in mechanical engineering, aerospace engineering, electrical circuits, population growth models, heat transfer analysis, and fluid flow problems, control systems, and robotics. In whenever a differential equation appears in engineering, RK fourth order RK method is used to obtain the approximate solutions. And finally we can go for this mind map session. So in this mind map we can summarize the method. That is, here first thing we are choosing the RK method, and RK method we are specifically we choose the fourth order. In fourth order we are accuracy and stability both are we are calculating. So the mechanism of this RK method is time stepping and multiple evaluations, high accuracies. So some applications we can tell for this RK method: mechanical vibrations, chemical reactors, and electrical circuits. So mainly we are calculating weighted average, and for next we evaluate the solution, and the process is repeated until the required interval is completed. So from this we can conclude the RK method. So based on this, some assessment questions we can discuss. The order of accuracy of the classical fourth order RK method is first order, second order, third order, fourth order. We choose here fourth order. Why is the RK method generally preferred over Euler's method? So if the given options are, it requires fewer computations, it gives exact solutions for all differential equations, it provides higher accuracy using weighted average, it eliminates truncation error completely. So already we discussed earlier, the higher accuracy using weighted average of slopes is the correct one. The answer is C. The general RK update formula is given which of the following correctly represents K2. So what is the formula for K2 they asked. So formula for K2 is function of xn plus h by 2 comma yn plus h by 2. We are replacing the previous step k1 value in for k2. This way we are getting the solutions. Some referral links are given, and we can go for the to learn this method we can go for this methods. Thank you.